Okay, so we left off in variables. We were discussing local variables, global variables, static variables, and we need to know the difference between the three. All right? Local variables, we know that they are created inside a block and they live only within that block. One of the features that we have is I can have in different blocks the same variable name because it's going to be in a totally different memory location. Each block is going to have one area of main memory. So I can have in main, I can declare variable x. In function A, I can declare variable x. And in function B, I can also declare variable x. And it will be three different variables. Each one is going to be declaring its own block, and it's going to live only within that block. Global variables, they are going to be created outside functions. They are not related to any specific functions, but they can be called from any functions, and they all share the same memory location. One of the disadvantages of using this type of variables is that it will be difficult to debug if we have a problem in our program, because it's the same variable location for all the functions. Then we have the third one, which is the static variable. The static variable, it lives, it's like a local variable, but the advantage of this type of variable is that it's going to keep its value. It's not going to lose the value once we exit the block. The initialization of the variable is only done once, the first time that we call that function. Like if we start x, it lives in function A, and we call this function the first time, x is going to be initialized, and let's suppose that after the execution of that function, x changes to number 10. When we call the function again, x is going to be with that value, the last value that it was placed in that variable. So in this case, the example is 10, so we're going to have it as a 10 in there. And the initialization is going to be bypassed, and it's going to continue accumulating or changing the value. Maybe this second pass is going to have 100. So the third time that we go back to that function, x is still going to have that 100 in there. So it keeps its value, but it's also a local variable. Only lives within that function. The only thing that we need to do is when we're declaring it is that we need to use the word static. Then we talk about passing a variable as a reference, not as a value. This is the main difference between the variables that we use, which are the local, the global, and the static. Every time that we pass it, remember we pass it by calling the function, which is, and we call that list arguments. And when it receives those values in the header of the function, it's called the parameters. So when we move that value, we're saying that we're moving it, or we're sending it by value. When we use reference variables, we're sending it as the address, not as the value, but as the address. Reference, I'm referring to a specific area in main memory. So we're not really sending a copy of that value. We're going to be sending the address where that value is. The advantage of this is that all functions that work with this reference variables are going to be able to update the value that we have in that address. So that if I go to, if I call function A and I'm sending a reference variable. I'm going to actually be sending an address in main memory. I change the value in there, so when I go back to main or my calling function, that new value is going to be there. Right? If I change it again in main and then I go back to another variable and I pass it as a reference, it's going to still work with that value. So reference variables is a good way to change different values, and when we return from that function, it's like we are returning those values or those new updated values. So this is going to help us overpass the limitation that we have that functions only return one value. The way that we're going to be working is by using the ampersand. The ampersand is the symbol that is going to indicate this is a reference variable. This is a reference variable. So in my prototype, I'm going to be putting the return data type, of course the name of the function, and then in parentheses we're going to list the data type of that reference variable and then the ampersand. Remember, this data type is going to indicate how big that area is. If it's an INT, that means I'm going to be separating 4 bytes starting at this location. That's why we have the ampersand. The same thing here. If I have a double, then it's going to be 8 bytes. If I have a character, it's going to be 1 byte. So the ampersand is going to indicate that. This is a prototype. Here's an example of the call, the prototype, and the function itself. So here we have the call. We're not going to be using the ampersand. We're just going to call it as we normally call any other function, and we list the arguments. So we have here square it, local variable. So we're making a call right here. The parameter that is going to be in main is going to have, again, the return data type, the name of the function, open parenthesis, the argument list, and we only need to write the data type and the ampersand. The function itself is going to have the data type, the name square it, which is the name of the function, then int, and the ampersand has to be next to the name. This name was decided by the programmer that created this function. We can call it anything, right? I can call it X, I can call it numbered, I can call it digit. It's up to the programmer that is going to be creating this function. But the only thing is that we have to use the ampersand. So as you can see, the ampersand is going to be used in the function header as well as the prototype, not in the call. Not in the call. So we talk about this on Thursday. Any questions on this? No? Okay. The next topic that we have is overloading functions. Overloading functions is when we have the same name for 2 or more functions. It's valid in C++. Remember, we cannot have the same variable name in the same block, right? Because then the computer is going to send a message saying, hey, I don't know which X you mean. I have 3 X's in the same block, in the same memory location, so I'm confused. But we can do same names for our functions. The only thing that is going to be required is that we have the parameter list be different. Be different. Let me give you an example. I'm going to be using the square it that we have right here. Okay, here I'm making a call, and I'm calling square it and I'm only passing one value, right? And this value, well, in this case, is going to be a reference, so I'm just passing one address right here. I can have another void right here Same name, square it. And have open parentheses, and instead of an INT, have a double. And then my ampersand. This is going to work for any type of variable, local, static, or reference. Here I have the same number of arguments and parameters, right? I'm sending one right here, and it can go either to this one or to this one because it has the same name. What is different between these two? This one and this one. It has the same name, square it and square it. One is INT and the second one is double. So this is the difference that we have right here. Let me stop it because I saw the photographer right here. So he can do it. I'm here. Okay. Okay. Thank you. We'll wait. Do they need to sign?
No, it's just for a presentation. It's just on a PowerPoint. It's not going to be advertising or anything.
So we just continue with our class? Yeah. Okay. Okay, then we can just continue. Let me turn this off right here. This one we apply. It's more terminology, so everything that we know, we just brought it in. So that's why we only had 2 programs in here. I show you a couple of programs at the beginning just so you could see the module setup. But we're going to be programming a little bit more in next chapter because we're going to be incorporating now arrays. Okay. So this is like a relaxing time for this semester. Last weekend, this month.
Oh, it is?
Mm-hmm.
Are we off on Friday? Or?
Yes. Do you have any questions?
What Friday are we off?
Okay, let's finish this up, and then we'll talk about charter days, all you want. Do you have any questions on this? Okay, on Thursday, we will have the quiz first, okay? And then you will have the rest of the time to work on the project, okay? Because it's due on Thursday.